Here we are getting ready to take our Unit 6 test. So this is the practice test prior to taking the test tomorrow. So number 1 says to complete the following without a calculator, and we're finding the exact values. That means we're not allowed to have decimals. And that's one of the reasons why for this test I'm saying no decimals, no calculators, because I really want you to use your unit circle as your reference. So the first one says cosine of pi over 6. So you're going to refer to your unit circle, and I just made a clean copy. But remember that our coordinates are written as cosine, and cosine comes first, that's the x coordinate, and then sine. So this is x, this is y. So I'm looking for pi over 6, which is a 30-degree angle, and cosine is going to be the square root of 3 over 2, and that's the exact value. So this is the square root of 3 over 2. Then I have tangent of pi over 4. So pi over 4 is right here. Tangent, and that's another thing we should have written down, tangent is sine over cosine. Okay, so the sine value is square root of 2 over 2. The cosine value is also square root of 2 over 2. Now, whenever I'm dividing a number by the exact same value, I'm going to get 1. So tangent of pi over 4 is 1. Then I have sine of 2 pi over 3. All right, 2 pi over 3 is right here. It's a 120-degree angle, but sine is the second coordinate, so that would be the square root of 3 over 2. And cosine of 31 pi over 6. Now, if I were to count by 6, this would be 6 pi over 6, 12 pi over 6, 18 pi over 6. Whoops, you can't see me going around the circle. Okay, so 6 pi over 6, 12 pi, 18 pi over 6, and I'm going to keep going until I get to 31 pi over 6. Now, another way to do this is to find a coterminal angle that's between 0 and 2 pi. So if I have something that's bigger than 2 pi, which I do, I'm going to take away multiples of 2 pi until I get something between 0 and 2 pi that would be on my unit circle. So if I start with 31 pi over 6, and I need to take away multiples of 2 pi, now that needs to be with a common denominator. So 2 pi is the same thing as 12 pi over 6. All right, so if I take away 12 pi over 6, I'm going to have 19 pi over 6. And I can take away another 12 pi over 6. And that would leave me with 7 pi over 6. And this is on my unit circle. So 7 pi over 6 is a 210-degree angle. And I am looking for cosine of that angle, which is the first coordinate, which is negative square root of 3 over 2. So I have cosine, this is the same thing as cosine of 7 pi over 6, which is negative square root of 3 over 2. Next one is cosine of pi over 2. Here's pi over 2, cosine is 0. And then tangent of 3 pi over 2. All right, so tangent of 3 pi over 2, Remember, I have cosine, then sine, and tangent is sine over cosine. So I have -1 over 0, and this would be undefined. All right, so just looking at the unit circle at certain angles and finding sine, cosine, and tangent from that. Number 2 asks us to convert 225 degrees to radians. All right, so we need to remember that 1 pi radian is equal to 180 degrees. So if I start off with 225 degrees and I multiply this as a ratio, so I'm going to multiply by 180 degrees, and my degrees have to go across from each other, is the same as 1 pi. So this value right here is just 1 whole. Okay, a value divided by an equal value is just 1. So now what I need to do is reduce my fraction, and I can say, let's divide this into, do you know what else would have been easier? And I can reduce this, but 225 is on my unit circle, and that's the same thing as 5 pi over 4 radians. All right, so first check to see if the number's on your unit circle, and otherwise we could have reduced our fraction. I could have probably divided by 5 and kept going with that, and divided by 25 actually, maybe not. Divided by 5 and just reduce your fraction. Anyways, you'll end up with 5 pi over 4. Now it says to take 5 pi over 4 and change it to degrees. Well, that was the same angle, so I know that this is going to be 225 degrees. But let's say I don't have 5 pi over 4. Let's say I have 5 pi over, I don't know, 12. And I want to change this to degrees, and I multiply now by pi and 180, and the pi's cancel, so I have 5 times 180 divided by 12, or 12 will go into 180. All right, I'm going to cheat here. 15 times. Oh, that was bad. So this is 15 times 5 pi, which would be, 15 times 5 is 75 degrees. My pi's canceled out here. Ooh. All right. Because we don't have a calculator, we're not going to worry about degrees and minutes and seconds. So numbers 4 and 5 are not going to be on your test. Number 6 says to find the length of an arc of a circle with radius of 3 and a central angle using pi. Now, we have a formula for that, and that is the arc length is the radius in radians. The radius times the angle in radians. So the arc length is S, and that's going to equal the radius, which is 3, and the angle is pi. And that would be what we would have. It says it doesn't say to calculate. So 3 pi is going to be the length of that arc, which would be a little bit more than 9, probably about 9.5. And that would be in units of meters. Number 7 also asks us to use a formula to do some calculations of finding the area of a central angle in a circle. So here's my unit circle. It says we have a radius of 10 and a central angle of 90. So really what I would want to be finding is this section right here. My radius is 10. My angle is 90, but it needs to be in radians, so that's going to be pi over 2 in terms of radians. So my area would just be 1/2 times my radius, which is 10 squared, times my angle, which is pi over 2. Okay, and we can calculate that. Half of 100 is 50 times pi over 2. So this would be 25 pi, and that would be in inches squared. Okay, and I'm just going to tell you, you don't have to do any crazy calculations for these. Number 8, it says that P, which is a point on the unit circle, has the coordinates of 1/2 and the square root of 3 over 2. It says to find the 6 trig functions. Well, if I were to draw a unit circle, and I know that because both of these are positive values, my point P is going to be in the first quadrant. So if I were to draw a triangle here, this is my angle. It has cosine of 1 over 2. Now cosine is adjacent over hypotenuse. So the side adjacent to this angle to the center is 1, and my hypotenuse is 2. And sine is opposite over hypotenuse. So the side opposite of this angle is going to be the square root of 3 over 2, which is the hypotenuse. Now, I know sine and cosine. Sine is 1/2. Cosine is, backwards. Sine is the square root of 3 over 2, second coordinate. Cosine is 1/2. Tangent is going to be sine over cosine. So I have the square root of 3 over 2 divided by 1/2, or multiplied by the reciprocal, which is the square root of 3. Now I have cotangent, which would be 1 over the square root of 3. And if I rationalize the denominator, I'm going to have the square root of 3 over 3. Sine goes with cosecant, and the reciprocal of sine is 2 over the square root of 3. And if I rationalize my denominator, I'm going to have 2 square root of 3 over 3. And then I have secant, which is the reciprocal of cosine, which is just 2. All right, so there's all 6 of the trig functions that come from this point that was on the unit circle. Number 9 just asks us to type these things in our calculator and to round them to 3 decimal places. All right, so what we've been doing using the unit circle and the square roots and the ratios gives us an exact value. This is just calculating a decimal value, which is an approximate value. We're not going to do that on our test, so I'm just going to cross that out. Okay, number 10 says if sine of an angle, and this symbol here is theta, is 1/3, and the angle is in quadrant 2, find tangent. All right, so I'm going to draw a unit circle, and my angle is in quadrant 2. So here's my angle that I'm working with. I'm going to draw that in a different color. So that's my angle, and sine of this angle is 1/3. So sine is opposite over hypotenuse. So the opposite of this angle is 1, and the hypotenuse is 3. And then I have to find this length if I'm going to find tangent. So I'm going to use the Pythagorean theorem, and I'm going to say that 1 squared plus x squared here equals 3 squared, which is 9. All right, so 1 plus x squared is 9. X is, this is 8, x squared is 8, and x is plus or minus 2 square root of 2. Now, because this is the length of the x-axis, and it's on the negative side here, this is going to be negative 2 square root of 2. Okay, positive 2 square root of 2 would be in this direction. All right, so my 3 sides is 1, negative 2 square root of 2, and 3. I'm finding the tangent of this angle, so I need opposite over adjacent. So the side opposite is 1 over the side adjacent, which is negative 2 square root of 2. And because I have a square root in the denominator, I'm going to multiply both sides by the square root of 2. So this becomes 2. So this is going to be the square root of 2 over 4, and I have a negative. And usually I just put the negative associated with the top number. Doesn't matter. I could have a negative on bottom, and it's the same value. Number 11, in which quadrant is sine greater than 0 and tangent greater than 0? All right, so I'm going to go back to my unit circle and see if I can zoom out a little. Sine and tangent, let's see here. Sine is greater than 0, so that's positive, and tangent is less than 0, so tangent is negative. So I'm going to use my trick that all students take calculus. Okay, so in quadrant 1, sine, cosine, and tangent are positive. In quadrant 2, only sine is positive. Okay, so that means tangent and cosine are going to be negative. In quadrant 3, only tangent is positive. So that means sine and cosine are negative. And in quadrant 4, only cosine is positive. And sine and tangent are negative. So what am I looking for again? I'm looking for sine being positive. Sine is positive in the first and second quadrant only. And tangent has to be negative. So in the first quadrant, tangent would be positive, but in the second quadrant, sine is positive, cosine and tangent are going to be negative. Okay, and that's what we're looking for. So this would be quadrant 2. Number 12, we're getting into some graphing here. Number 12 asks us to graph -3 cosine of 2x. All right, so we're looking for our main descriptors here. Our A value here is going to be our amplitude, and the amplitude is -3. It's the absolute value. It's positive. That means from the x-axis, I'm going up and down 3 units, but it's going to be flipped because of that negative. My period, or the time that it takes to get from the start of one cycle to the end of one cycle, is going to be 2 pi, because cosine has a period of 2 pi, divided by this b value, which is 2. So my period is pi. And I'm going to start at pi, or I'm going to start at 0, because I don't have any phase shift. I have nothing in the parentheses that says add or subtract to 2x. So I'm going to start at 0, and I'm going to go to pi. And remember, I have to label the 3 points in between my start and my finish. So halfway between 0 and pi is pi over 2. Halfway between 0 and pi over 2 is pi over 4. And this is 3 pi over 4. Okay, now cosine, and if I don't remember where it starts, okay, the cosine of an angle, if I have an angle of 0, and I'm just going to bring my sheet back here, angle of 0, cosine is going to be 1. All right, so if I didn't have this 3 here, it would just go up 1, but now I have to multiply it by 3, so it's going to go up 3, but actually it's going down 3 because I'm flipping. So I'm going to go down 3. And then at pi over 4, I'm going to go to 0. At pi over 2, I'm going to go to 1, back to 0, and then back to -3. So my cosine graph is going to look like that. All right, next one, tangent of a number of an angle plus 1. So amplitude is 1. My period for tangent is pi divided by b. I don't have a b value, so my period is pi. And then I'm going to move it up 1 unit. So if I draw my axes, so if I start at 0, whoops, I'm just putting a 0 here, that's not a point, and I'm going to pi, I'm gonna have pi over 2, and then pi over 4, and 3 pi over 4. Now, the tangent is undefined at pi over 2. So, and that's because pi over 2, tangent would be sine, which is 1, over cosine, which is 0. So at pi over 2, tangent is undefined. So I'm going to have an asymptote here at pi over 2 and at any odd value of pi over 2. So this is 1 pi over 2, 2 pi over 2. Over here would be 3 pi over 2. I would have a asymptote there. Or I can go back to negative pi over 2 and have an asymptote here. All right, so my tangent graph needs to be between two asymptotes, and my asymptotes are at pi over 2. All right, so if I have tangent of 0, I'm going to get 0, but then I need to move it up 1. Okay. If I have pi over 4, tangent of pi over 4, and if I look at this, this is when I have the same number over itself, so this is going to be 1, but tangent of pi over 4 plus 1 is going to be 2. And tangent of negative pi over 4 is going to be negative 2. Oops, I should have marked it down here. So I'm going to, oops, negative 2 plus 1 is right here. So my tangent is going to come up. I'm going to go across here and go up like that. All right, I can have another one over here. This is 3 pi over 4. This would be 5 pi over 4. Okay, so tangent of pi is 0, but then I'm going to add 1. Then tangent of 5 pi over 4 is going to be positive 1, plus 1 is 2. This is negative 1, plus 1 is 0. So I'm going to come up here and run like that. All right, next one. I have cotangent. And this time I have a phase shift. All right, so let's start with our amplitude. Our amplitude is going to be 1 because there's no number out in front of cotangent. That's my A value is just 1. My period for tangent and cotangent is pi divided by the B value. So pi over B, which is pi divided by 1/4, which is 4 pi. Okay, so I have a long period here. And then my phase shift, that's a phi, is going to be minus C. So the opposite, this is my C value here, opposite of pi over 2, minus pi over 2, divided by B, which is 1/4. So this, if I multiply by the reciprocal, minus pi over 2 times 4 over 1, this is going to be negative 2 pi. So here I'm going to start, this is where I start, and I'm going to end at negative 2 pi plus my period, which is 4 pi. I'm going to end at 2 pi. So let's draw our axes. I'm going to start at negative 2 pi. And here's 0. I'm going to end at positive 2 pi. And now I have my 5 points. Positive and negative 2 pi, positive and negative pi, and then 0. All right, so cotangent has asymptotes that are at 0 and multiples of pi, okay? So in this case, it's going to be 0, the axes, that's an asymptote, and then I'm going to have, let's try this. I'm going to have another asymptote. Oh no, I did that wrong actually, because I'm shifting my asymptote over to 2 pi. So really, I forgot to move this over this way. So I don't have an asymptote here, but I have an asymptote at negative 2 pi and positive 2 pi. So generally, if I have cotangent is going to be just like tangent, and I'm going to look back at that graph. I can find it. So back at this graph for tangent, I'm going to have my middle as an x-intercept, and then I don't have a shift in the one that I'm doing. So I'm going to have in the middle of my 2 asymptotes an x-intercept. So I'm going to have an x-intercept right here. And then cotangent goes in the opposite direction. So I'm going to start high and then go down low. So start high. At negative pi, I'm going to have a cotangent at 1. At pi, I'm going to have a cotangent of negative 1. And it's going to look like this. And that is a cycle of cotangent. Number 15, sine of 2x minus pi. So I have no amplitude, or my amplitude is 1, and my period is going to be 2 pi over b, and my b is 2. So 2 pi over 2 is pi. And I'm going to shift, so my phase shift is going to be the opposite of the c value, so this is going to be pi over the b value, which is 2. So my phase shift is going to be right pi over 2 units. All right, so this is where I start. I'm going to end at pi over 2 plus pi. I'm going to start at pi over 2. I'm going to have a period that is pi units long. So if I add them together, I'm going to get, this is 2 pi over 2. I'm going to get 3 pi over 2. So this is what this looks like. I'm going to start at pi over 2. And I'm going to end at 3 pi over 2. Halfway in between them, now to find the midpoint, I add them up, so I get 4 pi over 2, and I'm going to divide by 2, or multiply by 1/2, and this would be 4 pi over 4, which is pi. And then halfway in between pi over 2 and pi is going to be, if I add these up, I'm going to get, this is 2 pi over 2 plus 1 pi over 2, that's going to be 3 pi over 2 times 1/2, or divided by 2, and that's going to be 3 pi over 4. This one will be 5 pi over 2 divided by 2, which is going to be 5 pi over 4. All right, so my amplitude is 1. So at my starting point at pi over 2, I'm going to have an x-intercept. For a sine graph, you have 3 x-intercepts in one cycle. Then I'm going to go up to 1, back down, down to -1, and then back up. Okay, so for a sine function, you have 3 x-intercepts, and then you go up or down whatever your amplitude is. In a cosine function, you will have 2 x-intercepts. You'll start at a maximum value, whatever your amplitude is. You'll come down, you'll go down to a low point, which is the amplitude in the negative direction, back up through the x-intercept, and then back to your max. So you'll have 2 maxes and a minimum, but you only have 2 x-intercepts. Sine, you have 3. Number 16, cosecant. Cosecant is the reciprocal of sine. Okay, so first we're going to look at the sine function. All right, the only thing here, my amplitude is 1, but it's flipped. And my period for sine is 2 pi over b, and my b value is just 1. And there's no phase shift or vertical up or down. So I'm going to draw a sine graph. Amplitude of 1. I'm going to start at 0, go to 2 pi. Halfway is pi. Remember, I just set up here, you have 3 x-intercepts. Oops, that's down here. And halfway in between your first point and the middle point, this is going to be pi over 2, and that's going to be at your amplitude. And then negative is this one, and this would be 3 pi over 2. All right, so this would be my sine function. Now, I got to get those asymptotes in there, and my asymptotes are going to be not at the maximum or minimum value. So it's going to be a shift over from the maximum and minimum value. So here I'm going to have a vertical asymptote, and here I'm going to have a vertical asymptote. Where my sine graph crosses the x-axis is where my vertical asymptotes are. And then to get the cosecant, oh, and I didn't flip. So actually my sine graph is down here, like this. Okay, so at this point, I'm going to go down, and I just forgot to flip because of that negative. And at this point, I'm going to go up. Last one. Here I have secant, which is 1 over cosine. So I'm going to use a cosine graph as a starter. And then my amplitude is 1. My period is 2 pi over b, which is 1, which is 2 pi. And my phase shift is the opposite of pi over 2, which is negative pi over 2. divided by b, which is 1. So this is negative pi over 2. So I'm going to start at negative pi over 2. I'm going to end at negative pi over 2 plus my period, which is 2 pi. So this is going to be 5 pi. Oops. So this would be 4 pi over 2. So negative 1, this is 3 pi over 2. Negative 1 plus 4 pi is negative 3 pi, or positive 3 pi over 2. All right, so what does that look like? I'm gonna start at negative pi over 2. I'm gonna end at 3 pi over 2. Now I gotta get halfway. So to get halfway, I need the midpoint. So I'm gonna add them up, divide by 2. So I have negative pi over 2 plus 3 pi over 2 divided by 2. So this is going to be negative 2 pi over 2. So this is just pi on top divided by 2. So this is pi over 2. Halfway between pi over 2 and negative pi over 2 is just the origin. And then this point would be between pi over 2 and 3 pi over 2. This is going to be pi. So if I were to graph one cycle of cosine, my amplitude is 1. For cosine, I'm going to start at my maximum amplitude, come down to an x-intercept. I'm going to go down, come back up to an x-intercept, and then here's my max. So my cosine graph is going to look like this. But what am I looking for? I'm looking for the reciprocal of that. So just like up here, my minimum and maximum values are at the center between the asymptotes. So here is a maximum value. My asymptote would be over here and over here where I have an x-intercept. Asymptote here, x-intercept. Now from these points for the maximum and minimum, I'm going to draw the secant graph. All right, so each maximum or minimum will have that parabola opening up or opening down towards the asymptotes. All right, lots of graphing practice.